Hey, what's up? It's your old pal, Mr. Cook. We just finished up the third page of the review. Now we're going on to four, and maybe we'll be able to do four and five on this one. We'll see. So solve the following equation on the interval from from 0 to 2 pi. So this is a standard trig equations problem. So let's see what we'd have to do here. I'm thinking that since I've got sines and cosines here, I'd probably want to change this cosine into sines also. So there's an identity that's really helpful. It's called the Pythagorean identity. That's this guy right over here. Sine squared plus cosine squared equals 1. It's a really good way to relate cosines back over to sines. You can use other identities, obviously, but this one is the most direct, and I think it's pretty easy to solve. So if you've got sine squared of x plus cosine squared of x is equal to 1, then just solve it for cosine squared. So cosine squared is going to be equal to 1 minus sine squared. So that's what I'm going to do. I'm going to plug in 1 minus sine squared for that equation. So I get 2 times the sine of x plus 2 equals, and then that's going to be 1 minus sine squared of x. Now check this out. If I just, move all this stuff over to the other side, I get a quadratic expression. So if I'm going to subtract 1, that puts it at plus 1 there. And then if I add over the sine squared, then I get sine squared of x plus 2 sine of x plus 1 equals 0. And if you just pretend that those sine squared of x's are x's, right, or y's or whatever, this becomes x squared plus 2x plus 1, okay? And just the way that you would factor that, so this factors to be x plus 1, x plus 1. The same thing will happen with the sine values, okay? So like this will factor to become sine of x plus 1, and then times sine of x plus 1. And obviously, since these are the same thing, I can rewrite it as a square. So it's the same as saying sine of x plus 1 quantity squared. Okay, now let's solve for the x value. So what we would do is we'd take the square root of both sides. So we get sine of x plus 1 is equal to plus or minus 0, which is just 0. Then if we subtract 1 from both sides, we've got that the sine of x is equal to negative 1. And if you go to your unit circle, there's actually only one angle measurement that has a sine that's equal to negative 1, and that's going to be this guy down here. So it's going to be 3 pi halves or 270 degrees. So depending on if you're answering the question in, and it looks like it's going to be in radians, we would give our radian answer. So that means that x, its only answer is going to be that 3 pi over 2. Okay, so there you go. There's number 17, solving it, solving the trig equations. Okay, next up, looks like we've got some stuff with matrices. So, since you're allowed to use your calculator, just, use your calculator on this. Some of it you can do by hand, probably faster than using your calculator, but I do want you guys to get familiar with using your calculators with matrices. Just because, if you take stats, you've got to use matrices with stats. You take calculus, you don't really do much with matrices and calculus, but it's a good tool to use to solve systems of equations and stuff. But anyways, so you can just go to your calculator, go to matrix. Matrix A is a 2 by 2 matrix, 2 rows, 2 columns. And then the values 4 and negative 2 and 5 and 7. And then the other one, matrix B, is another 2 by 2. And then it's 6 and 1 and negative 3 and 4. 4, there we go. Okay, and then it's asking me to do 2 of A minus 4B. So 2 times matrix A minus 4 times matrix B. Enter, and there's my answer for it. Okay, so I get, looks like negative 16, negative 8, 22, negative 2. There we go. Find the inverse of A and then find the inverse of B. So inverse, yeah, we can do the same thing with our calculators. So matrix A, and then the inverse button, the negative first, enter. And I don't know if you knew this neat trick, but you can change those to fractions if you do math frac. There you go. So there's your inverse of A. So A inverse is equal to, and then it's 7 over 38, 1 over 19, negative 5 over 38, and 2 over 19. All right, B inverse. Let's do that one next. So matrix B inverse. Change it to a fraction. Okay, so matrix B inverse is going to be 4 over 27, negative 1 over 27, 1 over 9, and 2 over 9. Easy stuff. There we go. There's the inverse. Find the determinant of A and find the determinant of B. Again, you can just use your calculator for this. So the determinant of A, it's just going to be a scalar value, just a number. So just type it in your calculator. So go to matrix and determinant and matrix A. And you get 38. And then determinant of B. Same thing. So matrix, determinant, matrix B. Oops. Yeah. 27. Okay, there you go. All right, next up, number 19. John and Harry are saving money from their summer jobs. John makes 15 per hour. Harry makes 12 per hour. The two of them are planning on setting aside 1 hour's wages for every day worked, and they plan to work on the same days. At the beginning of summer, Harry has $520 in savings. John has $200 in savings. How many days must each of them work for them to save the same amount in their accounts? Wait. That's 320 difference. Change that first one to I know this. It'll make a difference in terms of like giving a complete number of days. Change that to a 521, and the number should come out evenly. I know that's not exactly what it's asking for, but let's make nice numbers because it says how many days, and I don't want a fraction for that. So it doesn't matter. You're just going to be doing the same thing either way, but I just want like a complete number of days. Anyways, so you start off by making the equations. So Harry starts off with $521, so H is equal to 521, and he's making $12 per hour. So if he's saving 1 hour per day, that's going to be $12 for every day. Let's call X the number of days that he has worked. John has $200 in savings, and he's making $15 per hour. So we're going to add on 15 times X, the same number of days. So when they have the same amount, that's when the equations are going to be equal to each other. So we set the equations equal. 521 plus 12x is equal to 200 plus 15x. So, now you just solve it. So subtract 12x from both sides. 521 is equal to 200 plus 3x. Subtract 200 from both sides. 321 is equal to 3x. Divide both sides by 3 and you get 107. So the number of days that they have to work together is 107. So 107 days should be the amount. Solve the following system of equations. Yeah, you can just use your calculator for this one. So, you type it in, matrix. Now let's use matrix A again. So this has 3 rows and it has 3 variables and an answer. So this is going to be a 3 by 4 matrix. So, you start typing in the coefficients, 1A, 3B, negative 4C, and then the coefficient value, or the constant value, which is 5, and then negative 5A, negative 3B, negative 3C, and negative 3 for the constant, negative 4 for A, negative 4 for B, and then negative 1 for C, and that's going to be equal to negative 2. Okay, and then what we do to solve it is we use reduced row echelon form, or RREF, on our calculator. So you go to math, and RREF is kind of towards the bottom. There it is. And then matrix A, enter, And this will give you all the values that you need. So A is equal to 3. B is equal to -2. I didn't see what C was before it went away. -2 also. Okay. So those are all your numbers. Just use your calculator for it. 3 families went to lunch. 1 family ordered a chicken sandwich, 3 grilled cheese, and 4 drinks. The second family ordered, all that stuff. And then the third family ordered that stuff. How much is 1 chicken sandwich, 1 grilled cheese? Okay, so let's call the chicken sandwich C, the grilled cheese we'll call G, and then the drink we'll call D, okay? We make 3 equations and basically do the same thing that we did in number 20. So the first family had 1 chicken sandwich, so 1 C, 3 grilled cheese sandwiches, so 3 G's, and 4 drinks, 4 D, and the total was $29.80. And then the second family had a chicken sandwich, so C, 5 grilled cheese sandwiches, so 5G, and 6 drinks, so 6D, and the total was $43.20. And then the third family had 2 chicken sandwiches, so 2C, 1 grilled cheese sandwich, 1G, and no drinks, so 0D, and the total was $19.50. So again, we just type this into our calculator, do RREF, and then we'll get all of our values, C and G and D. All right, let's go ahead and do it. So it's going to be another 3x4 matrix, so we keep the dimensions the same, 3x4, but different coefficients. So we've got 1, and then 3, and then 4, and then the constant value is 29.8. And then we've got 1, 5, 6, and then 43.20, or 43.2. And then the last one we have is 2 and 1 and 0. And then 1950. Okay. And then we do RREF again. And this is what we get. So 7.5 for the first variable, which is the chicken sandwich. So $7.50. And then the grilled cheese sandwich is $4.50. And the drink was $2.20. There we go. Okay. If a vector V is equal to that, what's the magnitude? So magnitude, all you got to do is just think about it's Pythagorean theorem essentially. So it's like you graph out the vector. So it goes over 5, 1, 2, 3, 4, 5, then up 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's like up there, okay? And you can make a right triangle with this, okay? So imagine that a line goes straight down here. This side is 5, this side is 12. The magnitude is going to be that length, okay? So just use Pythagorean theorem. 5 squared plus 12 squared is equal to the magnitude squared. So this is a 5, 12, 13 triangle. So the magnitude is going to end up being equal to 13. And here's the deal. Even if the vector was pointing in the opposite direction, like if it was, negative numbers or positive numbers, it doesn't really matter. Like if your vector had a side length of -5 and a height of 12, the magnitude is always positive. So always remember that. So, it'd still be 13 even if one of the sides was negative. Magnitude is always positive. Okay, I think I'll end this video here, and then I'll start up on the next one. So I'll see you in the next one. I'm going to get a little drink of water too because my throat's a little dry. All right, see you in the next video. Bye-bye.